Okay. Hi friends. Today we are going to discuss about change of state. Okay. Let's go for the content. Change of state. In the matter a state is present. State is classified into three types based on the matter: solid state, liquid state, gaseous state. In the universe, matter is present. That matter is made up of with a fundamental particle. Already we know that fundamental particles are here nothing but atoms and molecules and compounds, whatever it may be. Matter is classified into three types based on its physical nature: solid state, solid state, liquid state, gaseous state. Solid state, liquid state, gaseous state. Okay, let's go for discuss about this solid state. For example, it is a container. In this container, the particles which are present are closely packed. Between the particles, no gaps. Between the particles, no gaps. Due to more attraction forces are present and high density and high melting point, boiling point. This can cause more attraction forces between the particles. It is a solid state container. Between the particles, no gaps. Between the particles, no gaps. The particles are closely packed, no gaps due to closely packed. Solid state particles are contains high melting points and high boiling points. Melting points and boiling points are very high compared with liquid and solid state, and high density and high density. These particles are not compressible, not compressible. Okay, this is for solid. Let's go for a look on liquids. Liquids. Suppose this is a container. In this container, liquid particles are present. Between the liquid particles, small gaps are present. Small gaps are present. Gaps are present due to loosely packed. Loosely packed. And no particular shape, no shape, but fixed value. Fixed value. Here, solids are having fixed shape and fixed mass. Fixed shape, fixed mass, and size. But the liquid sir does not have a particular shape, and liquids are having fixed value. Clear. And the particles which are present in this container are loosely packed due to less attraction forces are present compared with the solid state particle, and the boiling point and melting points are boiling points and melting points are lesser than boiling points and melting points are solids lesser than solids and greater than gases. Density is low density. Compare with a solid. Compare with a solid. These are liquid states. Let's go for a look on gases. Similarly, gases. The gaseous container, the particles which are present are very loosely packed, and the gaseous particles are moves randomly, no particular direction for moving. Large gaps are present between the particle. Large gaps are present between the particles. Between the particles, and these are not have definite definite shape and volume. These are very easily compressible. Gaseous particles are very easily compressible compared with the liquids and solids. Very easily compressible than liquids and solids. Okay, these are the information about the solid state, liquid state, and gaseous state in the change of a state. Okay, let's go for a look on what is change, how it will occur by the effect of temperature and pressure. Change of state. Okay, we know what are solids, what are liquids, what are gases. You know what are solids, what are liquids, what are gases. Okay, for example, solid ice, liquid water. Here, water vapors. Water vapors. I taking these are the examples for chain of state. Ice is a solid substance at a 0 degree Celsius temperature. At a 0 degree Celsius temperature, ice must be converting into liquid in state. Ice must be converting into liquid in state due to at 0 degree and less than 0 degree Celsius temperature. Water molecules are must present in solid state. That the solid state of a water molecule substance is called as ice. This solid substance of ice is directly converting when the temperature rises from minus level to 0 degree Celsius. It is slowly converting into liquid state. At the 0 degree Celsius temperature, the water molecules are must present neither liquid in form or solid in form. Okay, the conversion of solid state particles into liquid in state directly is called melting. Is called melting. At the particular point of temperature, the solid substance which is directly converting to liquid in state is called the melting point. The particular point of temperature is called a melting point. At the point of temperature, the solid substance of ice is directly converting into water. This point of temperature is called melting point. Okay. In the reversible direction, the liquid state of a water directly convert into ice at the same temperature. This can also occur at a 0 degree Celsius temperature. This is called freezing. This is called freezing. At the point of temperature, the water content which is directly here converting into ice, this point of temperature is called the freezing point. Freezing point. Freezing point. Clear? Okay. Let's go for it. The solid substance which is directly converting into liquid state in presence of temperature. It means on heating a solid substance, directly converts into liquid state. Okay, is known as melting or fusion. Melting or fusion. Melting or fusion. Both are same. Continuously on heating, these liquid substances are directly converts into gaseous state. Gaseous state. Okay. The conversion of liquid to gas is called boiling. Due to we are increasing the temperature from 25 degrees Celsius to more. For example, water boils. It is below boiling point. 100 degrees Celsius temperature is the boiling point of water. At this particular point of temperature, this water is directly converting into vapor state, neither steaming form, neither gaseous state. This particular point of temperature is here called boiling point of water. Okay, boiling point. The temperature at which a substance which is directly converts to gaseous state from liquid is called boiling point. Okay, in the reversible process, this gaseous state or vapors are directly converts into liquid state. This process is called condensation. This condensation process can occur on cooling. When we cools the vapors of any substance, the vapors are directly converting into liquid state. This process is called as condensation. Similarly, the liquid state of particles are going to freeze at a least temperatures when we cooling again and again for more time, directly converted into solid state. This process is called freezing or solidification. Solidification means the liquid particles are directly converting into solid without impurities. When a solid substance forms on cooling continuously, the solid substance does not contain any impurities. Impurities are eliminates from the main component. Okay, and conversion of liquid to solid is also called as solidification. And this conversion of liquid to gas process is also called as evaporation or vaporization. Vaporization. Clear? Vaporization or evaporation. See here. The conversion of solid state directly into gaseous state is called sublimation. Gases. A solid substance which is directly converted into gaseous state without involvement of liquid state. When we heat continuously, a solid substance directly converts into gaseous state. This conversion process is called sublimation. Example, dry ice, dry ice. The form of dry ice is the form of dry ice is CO2. Solid carbon dioxide is called dry ice. Ammonium chloride, ammonium chloride formula is NH4Cl and naphthalene balls, naphthalene balls and as a camphor, camphor. Okay, these are the examples for sublimation reaction. Examples for sublimation reaction. When we keep dry ice in a open system at the room temperature, dry ice is directly converted into gaseous in state. When temperature rises from 0 degrees Celsius to 25 degrees Celsius temperature, the solid carbon dioxide directly converted into gaseous in state. Okay, this is the common process in the nature. Second one is ammonium chloride and naphthalene balls and camphor. When we lightening a camphor white crystals are directly combustible in presence of sufficient supply of oxygen content. Camphor is completely burning. When the combustion process occurs with the camphor crystals, a blacky color fumes are evolving directly. These blacky color fumes are called a gaseous state of camphor. Before lightening the camphor must present in a solid in state. These crystals are directly going to convert into gaseous in state. When it is completely combustible after the combustion process occur, the gaseous particles are releasing continuously when the camphor crystal is burning. In the temple, we are observing the pujari will give the arati to God by lightening a white camphor crystal. In the time we are observing a camphor crystal continuously burning with without converting into the liquid in state, is directly converted into gases in state. This process is called sublimation. This process is called sublimation. Let's go for naphthalene ball. In our homes, we are keeping naphthalene balls for so many purposes, for controlling your creatures and insects. These naphthalene balls are, when we kept in the open system, are directly converting into gases in state. We are observing the smell or brightness of the naphthalene balls. Hour to hour or day to day, the naphthalene and the camphor crystal size will decreases automatically when we kept in the open system. This process is directly occur from solid to gaseous state by this pour. These are the best examples for sublimation reaction. Let's go for discuss about desublimation. Desublimation is the reverse process of sublimation. In the desublimation or deposition process, we are observing the gaseous particles or liquid particles directly converts into solvent state. Above process is sublimation. Okay. Below one is desublimation. Desublimation or deposition. Here, the gaseous particles are directly converting to solid state without the involvement of the liquid state. It means the gaseous particle which is going to convert into solid state, it unable to convert into liquid state before convert into the solid state. Okay, best example is water vapors. Water vapors directly converts into form of ice. Directly converts into form of ice. It is a naturally occurring process. Naturally occurring process. After the conversion of a substance from solid to gas, that gaseous particles are vapors or steam. When we when we cool continuously, those are convert into solid state, convert into solid state. Clear? Okay, this is the change of state. Okay, in this change of state, we are observing two main things. When temperature rises on a state of any substance, will automatically convert into other in form. See here, solid state of a substance converting into liquid state on heating. On heating. For example, we are taking ice is the best example for this solid in the nature. At the 0 degree Celsius temperature, ice is must present water in state, neither liquid in state. Liquid in state. At a minus 30 degree Celsius temperature, water molecules are must present solid in state. That is called ice. When temperature rises from minus 30 degree Celsius to 0 degree Celsius temperature, the ice solid substances try to converting into liquid in state. When temperature rises from 0 degree Celsius to 25 degree Celsius temperature, your solid water molecules are try to converting into liquid in state. At the 25 degree Celsius temperature, absolutely water must present liquid in state. Liquid in state. It means when temperature rises, the solid substances automatically converting into liquid state here. It means temperature directly affects any state. See here, when temperature increases, automatically the pressure what is present on the state decreases. Temperature rises up and temperature rises up. Temperature increases, automatically pressure decreases down. Decreases down. By increasing the temperature, by decreasing the pressure, the solid substance is directly converting to liquid state. Similarly, the liquid state of a substance also directly converting into gas state continuously on heating. It means the temperature rises from 25 degrees Celsius to 100 degrees Celsius here. This is the boiling point of water. For example, water is taken for conversion of the state below the boiling point of the water. It means nearly equals to 90 degrees Celsius temperature. 90 degrees Celsius temperature, water starts boiling. Water starts boiling when 100 degrees Celsius temperature reaches, gaseous particles are formed. Gaseous particles are formed. When temperature rises from its boiling point, it is nearly equals to 120 degrees Celsius temperature. At 120 degrees Celsius temperature, a complete steam is present. A complete steam is present. At 100 degrees Celsius temperature, liquid particles are must present. A liquid in state, neither gases in state. Liquid in state, neither gases in state. When temperature rises from 100 degrees Celsius temperature to 120 degrees Celsius temperature, the liquid particle is directly appears in the form of steam or vapors. Appears in the form of steam or vapor. Okay. Temperature is continuously rising, solid to liquid, liquid to gas. The pressure is decreasing. Pressure is decreasing one state to other state. It means temperature inversely proportional to pressure on change of state. Temperature is inversely proportional to pressure on change of state. When temperature increases, the kinetic energy increases. Kinetic energy increases. When kinetic energy increases, the intermolecular attraction forces are decreases. Intermolecular attraction forces are decreases. Intermolecular attraction forces are decreases down. Decreases down. Clear. Temperature directly proportional to kinetic energy. When temperature increases, kinetic energy also increases. When kinetic energy increases, the intermolecular attraction forces are decreases between the particles. Decreases between the particles. So that's why the liquid particles which are tightly packed in the container are going to lose by increasing of kinetic energy. Increasing of kinetic energy. It means slowly the particles are going away from each other, going away from each other. It means there is a transfer gaps between the particles from solid state to liquid, liquid to gas. The large gaps are present between the gaseous particles. That is why the gaseous particles are more compressible very easily. For compressing this gaseous particle, very small portion is required. Small portion is required for storing or compressing a large amount of gaseous particle compared with the liquid and the solid state. Solid state particles are not compressible very easily. Liquid particles are compressible. This particle very easily compressible. For example, compressed natural gas, CNG gas. The CNG gas cylinders what we are using in the transportation vehicle nowadays. This is a non-pollutant green gas, non-pollutant green gas. It is a eco-friendly gas nowadays. A large amount of compressed natural gas is using. Okay, a liquid. Liquids are not compressible very easily, and solids does not flow. Solids does not flow due to there is no chance for move one point to other point, one point to other point. When we apply a force on the solid state, then only solids can move. Liquids, liquids can flow very easily from higher level to lower level to higher level, based on the gravitation force, based on the gravitation force. Okay, liquids can flow very easily from high level to lower level. Similarly, gaseous particles can also flow here and there. No direction for gaseous particle, roaming here and there. They can flow any direction, no direction. They can flow any direction or at a 300-degree direction. It means all directions. All directions are possible for flow of the gaseous particles in the nature. This is the change of state. This is the change of state. Okay, let's go for a look on individual terms. Melting, melting. The process in which a solid convert convert into liquid liquid in presence of in presence of temperature and atmospheric pressure atmospheric pressure atmospheric pressure is called melting is called melting. Second one, melting point. Maybe you're understanding the concept. Next one is melting point. The temperature at which at which a solid substance solid substance convert converts into li- liquid liquid state. The temperature at which a solid substance converts into liquid is called melting point. Is called melting point or capital MP. This is the process in which a solid converts into liquid in presence of temperature and atmospheric pressure is called melting or fusion. Melting or fusion. Okay, third one, boiling. Boiling. The process in which the process in which A liquid converts into gaseous state, converts into gaseous state in presence of temperature and pressure is called boiling. Is called boiling. The next one, boiling point. Next one, boiling point. What is boiling point? The temperature at which the temperature at which the temperature at which a liquid substance convert into gaseous state convert into gaseous state is called boiling point. Is called boiling point. Is called boiling point. Okay. Fifth one, sublimation. Fifth one, sublimation. The process in which a solid substance or a solid substance directly convert into gaseous state without involvement of liquid state. Without involvement of liquid state. In presence of temperature and pressure is called sublimation. Okay. What is sublimation? The process in which a solid substance directly convert into gaseous state without involvement of liquid state in presence of temperature and pressure is called sublimation. Okay. Sixth one, condensation. Conversion of gaseous state to liquid state on cooling by increasing pressure is known as condensation. Freezing. What is freezing? Conversion of liquid state into solid state on cooling by decreasing temperature and increasing pressure is known as freezing. Okay. At the point of temperature, freezing point. This freezing can occur at the point of temperature, no? So that's why the point of temperature. Got it. The temperature at which a liquid convert into solid, convert into solid on cooling, on cooling, on cooling to very low temperature, to very low temperature is called freezing point. Is called freezing point. What a freezing point is? What a freezing point is? 0 degree. 0 degree is equals to minus 30 degrees Celsius temperature. Okay. Next one, desublimation. The desublimation process. Desublimation. Conversion of gas state to solid state without involvement of liquid state is known as desublimation or deposition. Desublimation or deposition. Okay. Desublimation or deposition. Okay. This all changes can occur on a state based on temperature and pressure. The temperature and the pressure are effects on a change of state without affecting any temperature and pressure. The state of the substance unable to convert into other form. Temperature and pressure is necessary for conversion of a solid state or liquid state to gases, whatever it may be, for conversion into other form. Without effect of temperature and pressure, a state of a substance unable to convert into other form. Okay, if the temperature and pressure is unaffects on the change of state, we cannot able to prepare something for eating, something for in our daily life. We are using so many things, so many articles, clothes, drinking water, different kind of metals, non-metallic items. These all things can prepare in the laboratory. Few things are naturally prepared by the nature. These all things can happen by effect of temperature and pressure on a particular state. If we cannot apply a temperature and a pressure on a state, we can't imagine a change of state in the nature. If the change of state is not occurring in the nature, we can't imagine the matter. Without matter, no universe. Universe means in the universe matter is present. That matter is made up of with a fundamental particle. Fundamental particles are here must present in solid state, liquid state, gaseous state. Those are nothing but atoms and molecules. If matter is present, everything is present. If matter is absent, nothing is possible in the universe. Okay, thank you so much for listening my class, attending my class. Please encourage me. If you like this video, please subscribe my channel and give your comments for next class. Myself, I will try to uh, give more content and more suitable methods in the easy way. I will going to teach in the next class. Also, myself, I want to change regarding the topic. I want to change my teaching style by your comments and your appreciation. Your encouragement is necessary for developing one person in the society. Without audience cooperation and encouragement, no one can uh, give more and more knowledge to other persons. What subject I have in my brain, I'm going to distribute my complete knowledge to each and every child in the easy manner, in the easy way. Okay, thank you so much. Have a wonderful day. Thank you. Bye bye. See you.